Hi, Dave Skosic back with you. We're still on Delaware State University. I'm at the beautiful new Oscar building. We're going to hear more about that from Dr. Amir Khan, Assistant Professor, Department of Engineering and Physics. Welcome.
Thank you.
Tell me about this building that we're in. I think everybody's seen it.
So this building holds a program which is Optical Science Center of Applied Research, or OSCAR as we know about it. And the main research that we are involved into is to use light or manipulate light so that we can study different types of particles in chemical and biological environments. For instance, we want to study what is the chemical composition of Earth's atmosphere, or maybe atmosphere of outer space bodies, for instance Mars. We have projects that are involved into that thing.
In fact, I know you've got projects on Mars,
right? Yeah, we actually have a project that was headed by Dr. Nuruddin Malichi, and his project is to devise and engineer instruments that can go, and that actually went into Mars rover mission, that can study rock samples on the surface of Mars. And we also look at technology that these are optical or optics-based technology that we can study human body or human cell or cellular processes. So we have a diverse range of applications looking at atmosphere, atmospheric sensing, human biology, looking at cellular process for human health. And we are also interested in looking at optics technologies, how we can identify explosive for threat detection, and for also
explosive threat detection. Oh,
yes,
all right.
And also to look at food or agricultural quality. So the main goal of our center or OSCAR program is to provide innovative solutions for current societal challenges, so that we can develop new technologies and also develop new educational optics programs, because this is an academic institution. So our research ties into innovation, and both of them feed into our education programs.
And we're sitting here in the lab. I'm looking at all of this impressive equipment. Just one of the bays here, this three-story building. You've got what, about 27,000 square feet here?
So this building is about approximately 21,000 square feet.
21,000 square feet.
Yep.
Okay. And who comes here? Is it just laboratory experiments, or do you have students involved?
So our main focus actually is to engage research and education and sort of marry them together. So we have researchers, those who are faculty at Delaware State University. We have researchers, those who are from outside other academic institutions, national labs, and of course we have students, both graduate and undergraduate students, those who participate and actively work on different research projects.
So you've got national and international implications here.
Exactly.
Working space, working health-related issues. This is really impressive. I know this building went up very quickly, probably around a year from an empty lot to this this glassed-in building here.
Right. In less than a year from starting from groundbreaking, and maybe a month ago, we just have a fully functional building, and we are really excited about all the research and honestly new opportunities that they are going to come here. So.
Well, it's interesting that you're involving undergrad students in research. So you actually teach students in this building as well.
Yes, so we do not have classrooms here, but we have actually a lot of spaces where students can interact with the researchers, they can collaborate, they can talk, discuss their research, and we have seminar rooms where we invite speakers when they give talks, and so those are some of the opportunities that we provide for the students in their educational program while they are working on research projects.
So what degree program would your average student be pursuing?
So most of the students here, they pursue bachelor's in engineering and engineering physics. We have master's in optics program. We have PhD in optics and physics program.
So tell me about undergrad students. I understand that this is one of the few facilities, a research facility, that actually involves and integrates undergrad students as well as graduate students.
Right. So education is a key component of our program, and what we are trying to do here, which is sort of different from our traditional way of giving education, is that we involve students at a very early stage. For instance, we involve freshmen, sophomore, as soon as they come to the university in this program, we involve them with some of these projects. So they work with the faculty, they learn new things, they gain hands-on skills on different projects, and at the same time they go for classes. And a lot of these opportunities are actually funded, and they get certain stipend. And what that helps us is actually we get students, those who work on the project, and also help students that they learn some new technology, and they can sort of connect to the theoretical knowledge that they gave in the lecture classes. So it's basically a win-win situation. And what we are trying to do here is to combine research, innovation, and transform engineering education the way it is done these days, and provide new hands-on skills so that the students, when they graduate, undergraduate students, when they graduate, they are sort of prepared for the workforce.
That is really something. I like the fact that the application, you were talking about greenhouse gases, and you refer to some of this equipment behind us here. Tell me more about that.
So in our research project, we are developing sensors to detect greenhouse gases. As we all know that climate change and global warming is a key issue. And what we are trying to see here is that can we develop technologies that are small, portable enough that can deploy in diverse platforms. For instance, can we develop sensors that can go on small unmanned aerial vehicles platforms, so we can detect and profile the atmosphere in a wide geographical scale. So we can look at carbon dioxide emissions, methane emissions, or nitrous oxide emissions, because we are looking at how these emissions impact twofold, how they impact the environment and how they impact the human health. For instance, we have seen that ammonia, which is precursor of particulate matter in the atmosphere, can relate to lung cancer diseases in certain populations. So we are trying to first understand and sort of discriminate what are potential sources and sinks of these greenhouse gases, and then we can sort of identify and suggest what could be the potential policies.
Will that allow you to look at specific areas of the landscape and say this area
exactly,
here?
yeah.
Okay.
Yeah.
It's
so
producing
yes. So we basically sort of want to create a map in a particular region, for instance, Kent County or Delaware, and put these on mobile platform, and we can identify what are the hotspots of these emissions, whether they are coming from, for instance, natural resources, or they are coming from some man-made, some power plants, for instance, or maybe just a leak from natural gas pipelines.
So I can see that kind of application being very, very practical. And
exactly.
Okay. How many scientists are here? How many faculty members are
so in this building, we approximately have about 14 faculty members that are working on different research projects related to chemical sensing, biological sensing, looking at 3D images of human body cells. In addition, we have actually affiliate faculties, those who are directly not associated with this building, but we collaborate on different multidisciplinary projects.
So it sounds like you're going to have a growing interest in this building. I understand there's going to be another building put up too to accommodate all of this growth.
Right. So this is phase one, and we have actually a lot of interest. We still have a lot of research opportunities that are coming up, and we want to expand and diversify into.
Anything you would like to add?
I would like to add that this building is unique in the sense that we are trying to integrate research and innovation, and we also have space here for industry to work with us. So that also ties into our education, when we have actually space here for startup incubators, for industries to set up their offices. So when they come in, they will interact with the researchers, they interact with the students, and that also helps in future job opportunities for the students.
And I've got to interact with my producer, who tells me that we're out of time. But Dr. Amir Khan, thank you so very much for being with us today. I'll be right back after these messages.